Hello friends, I am Dr. Nilesh Dani, working as a lecturer at Government Polytechnic Rajkot. We are in the series of lectures for Diploma Engineering second semester, and we are discussing Advanced Mathematics Group 1 and 2. My subject of discussion is differentiation and its application. In the series of lectures, we have so far seen what is derivative. We have also seen some of the derivative of standard function, working rules, and other concept of derivative. Let us have a brief look on the part which we have discussed so far. So we have seen what is derivative. This is the definition which we have seen. Then we have seen some of the derivatives of standard functions. Also we have seen that working rules for derivative of the functions. Also we have chain rule, that is the derivative of composite function, and we have derivative of implicit function, in which we differentiate directly the equation given to us, then we separate dy by dx in order to get the derivative. Then we have seen derivative of parametric function, that is dy by dt upon dx by dt, where t is parameter. Now the question is how to differentiate the function of the type y is equal to x raised to x. Now to differentiate this type of function, yet we don't have any concept or formula or rule that can take care of such type of function. In order to get the derivative of the function of the type where the base and power both are the function of x, we need some other concept. So today we are going to discuss the concept which help us to differentiate such type of function. It is namely known as derivative, a logarithmic differentiation. Here x raised to x has base and power both are function of x. So the answer is we can get the derivative using logarithmic differentiation. Let us see what is logarithmic differentiation. Logarithmic differentiation for a function y is equal to fx, if we differentiate the function by first taking log both the side, and then if we differentiate, it is known as logarithmic differentiation. So in spite of differentiating directly the function, we first take log both the side and then we differentiate the function. This concept is known as logarithmic differentiation, and generally it can be used to differentiate the function of the type y is equal to fx raised to hx or gx raised to hx. So the function here is having variable base as well as power is also a variable or a function of x. So this type of situation can be handled with the logarithmic differentiation. Let us have some of the example based on the. So let us first differentiate y is equal to x raised to x. So let us find derivative of y with respect to x. For that, first we will take the log both the side. Here, as we know that base and power both are the function of x. So taking log both the side, we have log y is equal to log x raised to x. As we have seen earlier, ln is a log to the base e. So here we are taking log to the base e both the side. Now this power here can be taken as a multiple here in the so log y is equal to x into log x. Now differentiating this function. log y is a function of y. So if we differentiate with respect to x, first we differentiate log y with respect to y, that gives 1 upon y, and into dy by dx. This is nothing but chain rule, as we have seen last time. Now this is equal to, here we have product of two function, one is x, another is log x. So using the derivative of product of two function, we keep one function, that is log x, as it is, and into derivative of x, that is 1. Derivative of x is 1. Plus here x we keep as it is, into derivative of second function, that is log x is 1 upon x. So here derivative of log y with respect to x is 1 upon y into dy by dx using chain rule, and derivative of x into log x using the working rule of derivative of product of two function. It is x, derivative of x is 1 into log x is as it is, plus x is as it is into derivative of log x, it is 1 upon x. So this x and x both will get cancelled, and this y on the left hand side we can take on the right hand side. So here it is in the denominator. So if we take on the right hand side, it becomes it will come on the as a multiplication. So dy by dx is equal to y into log x plus 1. So substituting the value of y, that is x raised to x, here we get dy by dx is equal to x raised to x into log x plus 1. Here we have differentiated this function y is equal to x raised to x using logarithmic differentiation, as we have taken log both side first and then we have taken its derivative. This process is known as logarithmic differentiation. Let us have another example. Here I have taken y is equal to x raised to sine x, and we have to find dy by dx for that. Now here also the base and power both are function of x, so we need to use logarithmic differentiation. So taking log both the side, we have log y is equal to log x raised to sine x. Now the sine x we can take as a multiplication of log, so log y is equal to sine x into log x. Once again differentiating log y with respect to x, we have derivative of log y with respect to y first, that is 1 upon y, into dy by dx, that is derivative of y with respect to x. And here on right hand side we have product of two function, that is sine x and log x. So we keep first function, second function as it is, that is log x, and taking derivative of first function, that is sine x, that is cos x here, plus sine x we keep as it is into derivative of second function, that is log x, it is 1 upon x. So sine x, derivative of sine x is cos x, log x as it is, plus sine x as it is into derivative of log x, that is 1 upon x. Now multiplying by x and y throughout, we have, or taking y as a LCM and x as LCM, and this y on the left hand side, if we take on right hand side, it will be in the multiplication. So y into divided by x is equal to this x we have taken as LCM, so it will be x cos log x plus sine x. So here x raised to sine x can be differentiated. Now substituting the value of y, that is x raised to sine x, here in this equation we have dy by dx is equal to x sine x upon x into x cos log x plus sin x. So this is the derivative of y is equal to x raised to sin x. As here base and power both are variable or a function of x, we have taken logarithmic differentiation. Let us see one more example. Here I have taken sin x raised to x. Previously we have taken x raised to sin x. So taking log both side, we have log y is equal to log sin x raised to x. Now here x, this x is in the power, can be taken outside, so it is log y is equal to x into log sin x. In the same fashion, log y, if we differentiate with respect to x, first we have to differentiate with respect to y, that is 1 upon y, into derivative of y with respect to x is dy by dx. And on right hand side again we have product of two function, one is x, another is log sin x. And log sin x is composite function of log x and sin x. So here also we have to choose or use the chain rule. Now differentiating x with respect to x is 1 into log sin x will remain as it is, plus x remain as it is into derivative of log sin x, which is a composite function. So first we take derivative of log sin x as 1 upon sin x, because we know that derivative of log x is 1 upon x, and into derivative of sin x is cos x. So here we have used the chain rule in order to differentiate log sin x. Now simplifying this, we have dy by dx. This y on the left hand side we take on the right hand side. So y into, this is log sin x. So the first term is log sin x, into 1 is log sin x, plus x into cos x upon sin x, it is cot x. Cos x upon sin x is cot x. So here if we substitute the value of y, that is sin x raised to x, we get that result, that is derivative of y with respect to x is equal to sin x raised to x into log sin x plus x cot x. So this is the way to get the derivative of the function of the type where the base and power both are the function of x. Let us have one more example. Here y I have taken as a x raised to log x. So here to differentiate this function, let us use teletop. Y is equal to x raised to log x. So here x is a base which is a function of x, and log x is also a function of x. So we use logarithmic differentiation. Here we take log both side, that is ln x or ln y is equal to ln x raised to ln x. This ln x, as it is in power, we can take in the multiplication. So it is ln x into ln x. This ln x we have taken in the multiplication and into ln x. Now ln x into ln x is equal to, or log y is equal to log x whole square. Now differentiating with respect to x. Here we are differentiating with respect to x. So it is d by dx of log y, that is equal to d by dx of log x square. Now this is the function of y and we are differentiating with respect to x. So here we differentiate this function with respect to y first into dy by dx. This is called chain rule. This is called chain rule. And here derivative of this function, it is a composition of two functions. So derivative of x square is 2x, so it is 2 log x into derivative of log x. So this derivative is 1 upon y. So if we differentiate into dy by dx is equal to, this is 2 log x into derivative of log x with respect to x is 1 upon x, is 1 upon x. So this is derivative of y with respect to x is equal to y we take on the opposite side, so it is y into 2 log x upon x. So dy by dx is equal to 2y upon x into log x. So it is the derivative of x raised to log x. Let us once again repeat what we have done. We have taken y is equal to x raised to log x as a function, and we want to get derivative of y with respect to x. Taking log both the side, we have log y is equal to log of x raised to log x. Now this log x we can take in the multiplication. So log y is equal to log x into log x. Log x into log x is log x square, and log y, if we differentiate with respect to x, it is a function of y. So first we have to differentiate with respect to y into dy by dx, and this is a composition of two functions. So it is x square and log x. So derivative of x square is 2x. So derivative of log x square is 2 log x into derivative of log x. Now 1 upon y dy by dx is equal to 2x into derivative of log x with respect to x is 1 by x. Now if we take y on the opposite side, we have y into 2 log x upon x. So it is 2y upon x into log x. Now substituting the value for y, we have the answer, that is dy by dx is equal to 2, that y is x raised to log x upon x into log x. So this is the final answer of this. So we have here differentiated the function x raised to log x. In the same manner, we can have a derivative of some functions like this. So let us take our second example. Here I have taken the function log x raised to x. So I have changed the base and power. So the function y is equal to log x raised to x. Now here the base and the power both are function of x. So we have to differentiate. If we want to differentiate, we have to take log both sides. So log y is equal to log of log x raised to x. Now this x we can take outside of the or in the multiplication. So it is x into log of log x. Now as we know, we have to differentiate this function with respect to x, and as we have seen just now, derivative of this is 1 upon y dy by dx. That we have seen in the last example. This left hand side will remain same in almost all example, and here x into log of log x. So if we differentiate this, this function log of log x, that will remain same, into derivative of x, that is 1, plus x will remain as it is, into derivative of log x, which is a composite function. So first derivative of log x, it is log of 1 upon log of x, because we know that derivative of log x is 1 upon x, but in place of x we have log x, so it is 1 upon into derivative of log x, because in place of x we have log x, so we have to multiply by its derivative. Now 1 upon y dy by dx is equal to log of log x, that will be as it is, into 1, so there is no need to write 1 here, plus this is x into 1 upon log x into derivative of log x is 1 upon x. So this x and x will get cancelled, and here if we take y on opposite side, we have y into log x plus 1 upon log x. Now if we substitute the value of y here, we get dy by dx is equal to y, that is log x raised to x into log x plus 1 upon log x. So this is the final answer for this example. So here we have differentiated log x raised to x. Here we have taken log both side, because it is a function where the base and power both are function of x. So whenever you have a situation or a function which has base and power both are the function of x, you have to first take log both side, and then you have to use take the derivative of that. In the derivative you have to use the concept which we have already seen so far. Let us have one more example. So it is sin x raised to cos x. Here we have taken trigonometric function as a base and a power. So the function y is equal to sin x raised to cos x. So this both functions are function of x. So base and power both are function of x. So we take log both sides. So log y is equal to log sin x raised to cos x. Now this cos x can be taken as a multiplication of log. So it is log sin x. So it is cos x into log sin x. Now in order to get derivative, we differentiate with respect to x both sides. So we have 1 upon y dy by dx, as we have discussed it earlier, and this is product of two function. One is cos x and another is log sin x. So first log sin x we keep as it is, into derivative of cos x, that is minus sin x. That is minus sin x. So we have taken the derivative of cos x here, and these function we have kept as it is. Plus now cos x remain as it is, into derivative of log sin x. It is a composition of two function. We know that derivative of log x is equal to 1 upon x. So here derivative of log sin x is 1 upon sin x into derivative of sin x it is cos x. Derivative of sin x is cos. So this is the derivative of this function, that is sin x, because in place of x we have sin x here. So we are using chain rule. Now simplifying this, we have this is minus sin x into log sin x plus this is cos x into cos x, or we can say cos upon sin, that is cot x into cos x. So dy by dx, if we take this y on opposite side and if we substitute the value of y, that is sin x raised to cos x, we have minus sin x into log sin x plus cot x into cos x. So this is the final answer of this. So here we have taken a sin x raised to cos x, trigonometric functions we have taken, and that also can be treated in the same way. So irrespective of what the functions are given as a base or power, we can use the logarithmic differentiation to get the derivative. Logarithmic derivative is also useful for certain other types of example where we have a product of some functions and a division of some functions are given together. So in order to get the derivative, we can use logarithmic differentiation, because if we take log, multiplication can be converted into addition and division can be converted into subtraction. So that helps us to get the derivative. But here we confine our discussion to such type of example where we have the power and base both have a variable or a function of x. Let us see some more example. Here I have taken an example where we are not given the main function as has a base and power as a variable of x, but we are given a composite function where the second function, that is one function is sin x and another function, that is x raised to x, is of that nature, means it has base and power both variable. So let us solve this example. So y is equal to sin x raised to x. Now here this function, that is x raised to x, can be differentiated using logarithmic derivative, but here the main function we are given as a sin x and this is x raised to x. So it is a composition. So what we do here, we take u is equal to x raised to x. Now let us first differentiate this, because we need du by dx in this, and what is y will become, now y will become sin u, because u we have taken as x raised to x. So y is equal to sin u. Now derivative of y with respect to x, as we know the chain rule, it is derivative of y with respect to u into derivative of u with respect to x. So derivative of y, that is sin u, with respect to u is cos u. So this we can write directly here as a derivative of sin u is cos u. But to get du by dx, what we need? We need logarithmic differentiation. So let us first differentiate the function y with respect to du by dx. So let us get du by dx first. For that we take log both the side. So log u is equal to x log x. This example already we have discussed earlier, so I am omitting some of the step. So 1 upon u, it is du by dx, and log x as it is into derivative of x is 1, plus x is as it is into derivative of log x is 1 upon x. So it is du by dx is nothing but x raised to x into log x plus 1. This x will get cancelled. So this is du by dx. This value we can substitute here in order to get derivative of y with respect to x. So here dy by dx is equal to dy by du. dy by du is cos u because y is sin u. So derivative of sin u with respect to u is cos u into this is x raised to x into log x plus 1. I write it on the another page here. Dy by dx is equal to cos u into du by dx. Du by dx is this one, so it is x raised to x into log x plus 1. Now replacing the value of u, that is cos u, that is x raised to x into x raised to x into log x plus 1, that is derivative of y with respect to x. So this is the sometimes we may get a situation where the function directly not given in the form of x raised to x or variable power based to the variable power, but one of the part of the function is of that form. So here we can separately differentiate it using logarithmic differentiation, and then we can get that derivative in order to get the derivative of y with respect to x. So this is the example where we have taken a composite function, and in composite function one function is sin x and another function is a function that has variable base and variable power. Now let us have some exercise here. In this exercise, some of the examples are very tricky and it is also very important. So some of them let us calculate. So let us calculate first example, that is x raised to y into y raised to x is equal to 1. Here we want to find derivative of y with respect to x. Now as you know, here we are given two functions, both have variable base and both have variable power, and we are given product of this. If we are given product of this, we can easily work out, because we know that if we take log of product can be converted into the addition of the log. So here if we take log both side, we have log x raised to y into y raised to x is equal to log 1. Now we have product of two function, so it is log x raised to y plus log y raised to x. It is equal to log 1 is 0. Log 1 is 0. Now here this y we can take as a multiplication, so y log x plus this is x log y is equal to 0. Now actually this is implicit function. We can directly differentiate this equation and then we will collect all the terms which includes dy by dx. As we have seen, implicit function, in implicit function or for implicit function we differentiate directly the equation with respect to x, and in the process we differentiate the function of y with respect to y first and then with respect to x, that is dy by dx, and after that we solve it for dy by dx to get derivative. So the same thing will apply here. So here derivative of y with respect to x is dy by dx, keeping log x constant, plus now we keep y as it is into derivative of log x, that is 1 upon x, plus here log y we keep as it is into derivative of x, that is 1, plus x will remain as it is into derivative of y, that is 1 upon y, and into dy by dx is equal to 0. So here we have product of two function, one is y and another is log x. So log x we have kept as it is into derivative of y with respect to x, so that is dy by dx, plus x, that is plus derivative of log x, that is 1 upon x, and y, that is as it is. Now for the second term we have log y as it is into derivative of x, that is 1, plus this x is as it is and derivative of log y with respect to x. So first we differentiate with respect to y, so it is 1 upon y into dy by dx, and on the right hand side we have 0. So now we solve it for dy by dx. So we take the term including dy by dx on one side and remaining term on the opposite side. So here before that let us multiply the entire equation by x into y, because x is here in the denominator and here y is there in the denominator. So entire equation if we multiply by xy, we have xy log x dy by dx plus, I write this term now because it includes dy by dx. So here y will get cancelled, so x square will remain into dy by dx, plus here xx will get cancelled, so we have y square because we are multiplying by x into y, so x will get cancelled and y into y is, plus xy into log y is equal to 0 into anything is 0. Now here if we take dy by dx common from this two term, we have xy into log x plus x square, and the remaining term if we take on the opposite side, we have minus y square plus xy log x y log y. So if we solve it for dy by dx, the final answer is dy by dx. Now this if we is in the multiplication. So if we take on the opposite side, it will be in the division. So y square plus xy into log y divided by, this is x square plus xy into log x. So this is the derivative of y with respect to x. So here we have, in this function, we have x raised to y into y raised to x. So we have product of two function. They have variable base and variable power, but as they are as a product, we can take directly log. But if they are as a multiplication, means x raised to y plus y raised to x, we can't directly take multiplication, but we can take their separate derivatives and then add them to get the complete derivative. So whenever we have a product, we can directly take log both the side to get the logarithmic differentiation. Now one more example from the exercise, let us see. So the next example, that is y is equal to x raised to x infinite times. So the power of x raised to x raised to x raised to x infinite times. Now looking at first sight, it seems very difficult, but it is very easy if we understand it in a proper way. What exactly the function is? It is x raised to x raised to x raised to x infinite times. Now these can be rewritten or organized in a manner that we can easily differentiate. So let us see how we can manage it. Now before we differentiate, see here x raised to x raised to x is infinite times. Now if I take one x out of this function, means if I take this as a two part, one that is x raised to x raised to x raised to x infinity, and one x if I take separately. So if I take x separately, the remaining function which I have is nothing but equal to y. So if I hide this, or if I don't take this x, although we have infinity power of x raised to x raised to x, so also that will remain y. So rewrite this function as x raised to y, because this is nothing but y, because y is x raised to x raised to x raised to x infinite time. So now the things are very simple. So what we have done here, we have here taken x raised to x raised to x raised to x infinite times as a y, and that I now taking log both the side, we have log y is equal to y log x. If we take log here, y we can take as a, now this is also composite function, we can directly differentiate it. So it is 1 upon y dy by dx. Now we have product of this two, so we have y log x as it is into derivative of y, that is dy by dx, plus y as it is into derivative of log x is 1 upon x. So what exactly we have done here? This is log y is a function of y, so we have differentiated first with respect to y, that is 1 upon y dy by dx, and is equal to, this is product of two function, so considering derivative of first function, that is y with respect to x, keeping another as it is, that is log x, plus keeping second as it is, that is y, first as it is, into derivative of second, that is log x, is 1 upon x. Now if we take x LCM, if we take this term dy by dx on the opposite side, we have 1 upon y dy by dx minus log x dy by dx is equal to y upon x. So here we can get dy by dx common. So if we take dy by dx common, we have 1 upon y minus log x into dy by dx is equal to y upon x. So if we take this on the opposite side, we have dy by dx is equal to y upon x into 1 upon 1 by y minus log x. Or you can take y as LCM here, that gives you y square by here I am writing dy by dx is equal to y square by x. This y we have taken as LCM, so it is 1 upon 1 minus y log x, and this y we can take in the numerator, so that is y into y is y square. So it is y square by x into 1 minus y log x. So here we can get the derivative of this function, that is y is equal to x raised to x raised to x. Let us repeat the thing. What we have done here, the function is x raised to x raised to x raised to x raised to x infinite times. Now if I take one x out of this, right, what will be the remaining part? Remaining part is also y, because in this also we have x raised to x raised to x raised to x infinite times. So the function can be rewrite as this: y is equal to x raised to y. Now taking log both sides, we have log y is equal to y log x. Now 1 upon y divided by dx, that is derivative of log y with respect to y, is equal to log x is as it is into derivative of y with respect to x plus y is as it is into 1 upon y, 1 upon x. Now if we take this term on the left hand side, this is 1 upon y divided by dx minus log x divided by dx. Now, and this is equal to y by x. Now taking y divided by dx common from these two, we have 1 upon y minus log x divided by dx is equal to y by x. Now if we differentiate, if we take this term on the opposite side, it will be in the denominator, so it is y by x into 1 upon 1 by y minus log x. Now if we take y LCM here, this y will be multiplied here, so it is 1 minus y log x, and this y will be in the numerator, so it is y into y, it is y square, so it is y square by x. So this is the derivative of x raised to x raised to x raised to x infinite. Now in this session we have seen the derivative of the function which is having a base and power, both variable or a function of x, and in the process we take log first and differentiate with respect to x after this. This is logarithmic differentiation. Last example that in the exercise I leave for you, you try to get the derivative of this function. Here I am giving some hint for you, as we have y is a function of x raised to x plus x raised to root x plus root x raised to x. Here directly the function having base and power both variable is not given, but we are given two function of such kind and their addition is given. So here we can't directly take the log of the function, but what we can do, we can assume y is equal to u plus v, where u is equal to x raised to root x and v is equal to root x raised to x. Now what we can do here, we can take log both sides of this function, that is, and log v is equal to log root x raised to x. Get derivative of u with respect to x from this, get the derivative of v with respect to x, right, and then dy by dx is equal to du by dx plus dv by dx. So whatever derivative you get, that is for derivative of u with respect to x, you substitute here. Whatever derivative of v with respect to x you are getting here, you substitute here and get your final answer. So here you can't get directly log because two functions are separately given as an addition where their base and power both are variable. So we can't get directly log and get its derivative, but we can separate them, take their separate derivative using logarithmic derivative and then add them to get the final. So this is hint for you. You try yourself and you do more practice of this kind of functions where you have base and power both are variable or a function of x. Thank you very much.